Hi class, today we're going to take a look at the order of operations, but before we get into doing that, we're going to need to take a look at what an exponent is, because exponents are going to show up in our order of operations. And so when you have an exponent, there's going to be some different parts to our exponents. Our x here that we see right here is going to be a number that's written a little bit larger, and it's called a base. And then there's going to be a smaller number up here, which is what this n is, and it's going to be written kind of as a superscript kind of slightly above the base, and that number is what we call our exponent or our power. And the power or the exponent tells you how many of these values here, the base, to multiply together. So for instance, if I have 2 to the third power, that is telling us to multiply 3 of these 2's together, which is 2 times 2 times 2, which ends up being 8. Now on your calculator, you can calculate these exponents. Depending on which calculator you have, depends on what button you are going to be using. For instance, you may want to try it on your calculator with just this 2 cubed. You may find on your calculator a button that says y to the x, like that. And normally you will punch 2, then hit this button, and then hit 3, and then the equals button, and you should get 8 back out. If you don't get an 8 back out, try reversing the 3 and the 2 so that it's a 3, this button, and then the 2. Some calculators reverse it because x is before y, and so they'll want this value punched in first and this one second. But normally it's the base, this button, and then the exponent. Some other calculators will have a button that looks like this. This is also a key on your keyboard that also means exponent, and it is common for people to use this to mean exponent when they're typing. Also, if you're in the program Excel, Microsoft Excel, it uses this particular key to signify exponent. So if you're using that, you're going to do 2, this key here, 3, and then your equals button, and that should get you an 8. So check it on your calculator to know whether you're going to use this or that. If you're using Microsoft Excel, you're going to use this. Microsoft Excel, however, is going to have you put in an equals before you do your statement. So Microsoft Excel has an equals, and then you put in what you want it to calculate. So that's something that's slightly different there, but you will still use this button right here to calculate things using exponents in Excel. So now let's take a look at one little thing that's a little bit different on exponents. It's something that you have to be very careful about when calculating. There's a very common error that happens when you are dealing with an exponent that is even. In particular, most often it's used when you're squaring something, and squaring means you have an exponent or a power of 2. Now, when you have an exponent of a 2, let's say you have 4 squared, that's saying to multiply 2 of these bases together, which would be 4 times 4, which is 16, which is fairly easy. However, when you get to negative numbers, there's a very subtle difference between the way some problems are written that means to do something different. For instance, you might have negative 4 with parentheses squared, or you might have negative 4 squared without parentheses. This first one here, since the parentheses are around the negative 4 and the square is on the outside, that's meaning to actually take negative 4 times negative 4. You're multiplying the entire negative 4 times itself. And 2 negatives is an even number of negatives, so that gives you a positive answer, and the answer is positive 16. However, this one here is different. The exponent that you see up here is only applying to the value right before it. And the value right before it here is a 4. This negative here is not included. That negative is like having a negative 1 times 4 squared. When you have a negative x, you are having the same thing as a negative 1x. The same type of thing happens here. A negative x, that's the same thing as a negative 1x, which is similar to what you see happening here. The negative 4 squared without the parentheses is like having a negative 1 times a 4 squared, which is also the same as saying that you have the opposite of 4 squared. And 4 squared is 16. The opposite of 16, which is the opposite of 4 squared, is a negative 16. So when you're looking at a value where you're squaring something and there's a negative without parentheses like you see right here, then your answer is actually going to be negative because it's the opposite of this value squared. If you do have parentheses that are around the negative symbol, then you're going to end up squaring a negative value, which is going to give you an even number of negatives, which gives you a positive answer. Now, let's take a look at a couple more like that, just so we can make sure we have this straight before we do the order of operations. If we have negative 5 squared written like that, notice there's no parentheses, so that's going to be the opposite of 5 squared. And 5 squared is 25. The opposite of that is negative 25. If we have negative 6 squared written like that with the parentheses, we are actually squaring the negative this time, so that's going to be negative 6 times negative 6. The two negatives will make positive, and this will be positive 36. Some calculators do understand the differences between these, so it may be beneficial for you if you are punching in your calculator and trying to do the negatives to use the parentheses when they show up and not use the parentheses when they don't show up. But if you can just remember what we've talked about here, you'll be fine, and you actually probably won't need your calculator for it. Now that we know what the exponents are, let's take a look at the order of operations. And the order of operations has 4 different steps that you're going to follow. The order of operations first tells you to start inside parentheses. So if your problem has parentheses, that's where you're going to begin. Inside that parentheses, your order of operations starts all over again. So inside your parentheses, you look to see if there's some more parentheses. If not, you go to your exponents, which is your second thing to look at. After you have completed any exponents, then you want to do multiplication and division. Now, for multiplication and division, you want to make sure that you do those at the same time, and then you do them from left to right, the same direction you read as you come to them. And I'm going to do some problems here where I'm going to try and make sure that you learn to slow down and only do one step at a time. So we're going to move from left to right and do one little piece at a time. And also learn some attention to detail with this, because that's very important with these problems and actually any problem in math. And then the last thing you do once the multiplication and division is completely finished is you add or subtract. And again, just like multiplication and division, you do the addition and subtraction from left to right, the same direction you read, and you do them as you come to them. Now, let's take a look at a problem where we apply this order of operations. And the problem will look very scary, but as we go through, you'll see that it's actually not that bad. The key is to do one little thing at a time. So the problem we're going to try is going to be 5 times 3 squared minus 4 plus 2 times 3 cubed minus 12 divided by 4. Now there's a lot happening in this particular sentence, but you're going to find that as we go through this order that we have here and do one little thing at a time, it's really not going to be that bad. Now the first thing we want to do is parentheses. And inside that parentheses, our order starts all over. So I notice I have parentheses here. Inside this parentheses, I do not have any other parentheses. So I want to look for my exponents. And I have an exponent right here. It's 3 cubed. That means to multiply 3 3's together. And 3 times 3 times 3 is 27. So this is going to be 27. So I'm going to replace this with 27. And then I'm going to copy the rest of the problem down very carefully so that I don't drop any of my problem off or miss any of it. Now I'm going to stay within my parentheses, and I've done all my exponents, so the next thing to do is look for a multiplication or division. And I have some multiplication right here. So I'm going to go ahead and do that. 2 times 27 is 54. And then I'm going to copy the rest of the problem down very carefully. You'll notice as we do our problems this way that the problem gets much smaller and easier to deal with as we move along. Finally, inside my parentheses, I just have this addition to do here, so that becomes 58. Now that I'm down to one number, I technically don't need my parentheses anymore, and I'm going to copy the rest of the problem down. Now I want to take a look and see if I have any exponents, because I don't have any parentheses left. And I notice that I have a 3 squared right here. And since there's parentheses around this, there's an implied multiply here. So whatever I get for my answer here is going to be multiplied by this 5 right here, because parentheses also mean multiply. So I'm going to do 3 squared, which is 9, and then copy the rest of my problem down. Now I've come to my next step here, which is to multiply and divide, and I'm going to do that as I come to it from left to right. So as I go across, the first one I come to is right here, 5 times 9, and that's 45. So I'm going to multiply these two and make it 45, and I'm going to write that up here because I have some room up here. And then I'm going to transfer the rest of the problem up here. Notice that I haven't completed all of the multiplication and division. That's because I'm trying to pay very close attention to all the detail and only do one little thing at a time. Doing that throughout your problems and making sure to write each step out thoroughly like you see here will actually help prevent a lot of errors. It'll also help you be able to trace back and find out where any errors are if you made any. So it's very important to do that. Now I notice I still have this division right here, 12 divided by 4. So I'm going to go ahead and do that. 12 divided by 4 is 3. And then copy the rest of the problem down. Now, I'm going to be adding and subtracting. And if you'll remember that subtraction is the same thing as adding the opposite. So if I change all my subtraction to adding the opposite, I'll be able to think in terms of money when I deal with this to know whether my answer is positive or negative. So let's change all our subtraction to adding the opposite. This subtraction here will become adding the opposite of a positive 58 is negative 58. This subtraction right here will become a positive, and the opposite of a positive 3 right here is a negative 3. Now I'm able to think about money when I do my addition and subtraction. And going from left to right, the first one I come to is right here. 45 plus a negative 58 means that I have $45 and I would like to spend 58. We have a little bit of a problem with that. I'm going to owe somebody some money. In fact, I'm going to owe them 13, so that's a negative 13. Now I'm going to carry down the rest of the problem. And now you'll notice at the end that I owe somebody 13 and then I decide to borrow $3 more. Well, that means I'm now going to owe somebody $16. And the final answer here is negative 16. Notice that doing one little step at a time made it so the problem got a little bit easier and a little bit shorter as we moved along. Now, some of you may be saying, this is all fine and dandy, but how do I remember this order of operations so that I know how to do it on my problems? Well, there's a nice little saying that helps you remember this, this order here. The little saying that helps you remember this order is, please excuse my dear Aunt Sally. Now, please starts with a P. So that helps you remember parentheses because it's first. Excuse starts with an E, so does exponents, so that helps you remember that. My dear is a phrase you say at the same time. The my and the dear needs to go together, and that's the M and the D for multiplication and division. Since you say those together, that means you do these together, and in particular you're going to do them together going from left to right across your paper the same direction you read. Aunt Sally are also two words that you say together, and they are attached. They go together. The A and the S from Aunt and Sally means add and subtract, which is the A and the S for add and subtract. So that's a little saying that may help you remember this order. Another thing that people use is Pemdas. It's a little acronym. The P is for parentheses, E is for exponents, M and D are multiply and divide, and A and S are for add and subtract. Whichever way helps you remember the order is fine with me. Now, let's take a look at one more type of problem with these. Actually, we're going to do two more. The first one is going to deal with what we call a fraction bar. A fraction bar actually means divide, but it also can group the top and the bottom of the fraction separately. And as it groups it, what it does is it acts kind of like a parentheses. So if you have lots of things up in the numerator, like let's say that you have 5 squared minus 6 squared, this fraction bar is grouping the top of this expression here so that you know that this here has to be completed just as if it was in parentheses. Now, in the bottom of this fraction, or this expression, we're going to have 5 minus a negative 2, like that. So what we have down here is an expression that's been grouped down here by this fraction bar. So we're going to have to treat this as if it was also in parentheses. If it helps you to insert parentheses around the top of your expression and the bottom of your expression to remind yourself that this fraction bar, which means divide, also is grouping these as if they were in parentheses, then by all means feel free to do so. Now what we're going to do is first start up here, and inside this parentheses we have some exponents to do. We have a 5 squared and we have a 6 squared. So let's go ahead and do that. 5 squared is 25 and 6 squared is 36. And then if we go ahead and insert the parentheses if you would like it around the top, just to remind yourself they're there. That's fine. You don't need them there. Now in the denominator here, we're going to take a look at what we have here. We're subtracting, and remember subtracting is the same thing as adding the opposite. So I can change this to addition and change this negative 2 to the opposite of what it is, and the opposite of a negative 2 is a positive 2. So this becomes adding a positive 2. The double negative here cancels into a positive. And so in the denominator, really all I have is an addition problem. So 5 plus 2 down here ends up being 7. Now in the denominator I only have one number, so I don't have to do anything else there. However, if I look at the numerator up here, I do have some things to do up there. I need to subtract, and this subtraction here, remember, we can change to adding the opposite, and after it is a positive 36. So the opposite of a positive 36 is a negative 36. So I'm going to change this to addition and change this to a negative 36. Now you can think of this as I have $25 and I would like to spend 36. There's a problem with that. I'm going to owe somebody $11. And the denominator is going to stay at the 7. We've got it down to one number. Now, at the end here, you want to look and see what you have. If you can divide it or if you can reduce it, you want to do so. But we can't here. This particular thing is going to stay as an improper fraction because that's the way that we like our answers. Now, you can either write it with the negative symbol here, or another way to write it would be to have the negative symbol right here in front aligned with the fraction bar. You would not want to leave it in the denominator because remember that it doesn't quite make sense to have a negative in the denominator. So either move it so that it's lined up with the fraction bar or it's in the numerator. Either one is perfectly fine. Now let's take a look at one more type of problem where we have a little bit different type of a grouping symbol. And that grouping symbol is going to be what we call absolute value. And absolute value is represented by two straight lines. So you might have absolute value of 5 written like that. Now these straight lines here are asking you a question. Absolute value asks you a question of how far are you from 0? So you want to think of this in terms of a number line. If you had a number line and 0 was here and 1, 2, 3, 4, 5 was up here, this distance of how far 5 is from 0 would be 5 spaces. Distance is always positive. Even if you're moving backwards, you're still moving somewhere, so it's still going to be a positive value. So the distance of how far this 5 is from 0 is 5. However, what about absolute value of negative 5? Well, let's locate negative 5 here. 1, 2, 3, 4, 5. This would represent negative 5 down here. The distance from negative 5 to 0 is also 5. So the absolute value of negative 5 is also 5. Notice that it didn't matter whether we had a positive or a negative value inside the absolute value symbols. We still had a positive value when we answered this question of how far from 0 you are, because you can be 5 away from 0 either to the left or to the right of it. It doesn't matter. You'll get the same value. Now, these absolute value symbols, if there's more than one value inside, can also act as a grouping symbol just like parentheses. So we need to complete what's inside them before we actually ask our question of how far from 0. So we might have something like 5 minus 2, and then absolute value symbol, and then 4 minus 3 times 2, like that. Now, when you see the absolute value symbol right next to a number like this means multiply. Keep in mind that you have to multiply before you can subtract. So we do not want to do 5 minus 2. That would be not following the order of operations and you wouldn't want to do it. If it helps you to put a dot in here to remind yourself that that's multiplied, by all means do so. Anything to make it so that you refrain from doing the 5 minus 2 because you don't want to do that first. And actually, order of operations wants us to do parentheses first. And the absolute value symbols are acting as a grouping symbol, which is like a parenthesis. Inside here, the first thing we need to do is the multiplication because we don't have any other parentheses and we don't have any exponents. So 3 times 2 here gives us 6. So I'm going to replace this with a 6. And then very carefully copy the rest of this down, and if you need to keep your dot for multiply there, go right ahead just to remind yourself. Now, inside this parentheses, or actually these absolute value symbols, which are acting like a grouping symbol like parentheses, I still have to do 4 minus 6. And this subtraction is like adding the opposite of this 6, which is a negative 6. So you want to think of this as 4 plus negative 6, or you have $4, you would like to spend 6. The problem with that is you're going to owe somebody 2. So that's a negative 2 inside there. Now that we are down to one value inside the absolute value, you can actually answer the question of how far from 0 is this value. And negative 2 is 2 away from 0. So this absolute value of negative 2 will turn into a positive 2. And then you still are multiplying that by the 2 in front. Now, order of operations is going to require us to do this multiplication before we do the subtraction. So the 2 times 2 becomes 4. And then we can go ahead and do our subtraction to get a final answer of 1. So that's how you deal with your order of operations. And you are ready to try your problems that deal with that.